And this section will cover current manufacturing asset challenges. These are common challenges. 75% of US plants are more than 20 years old. That's not going to be surprising based on a lot of the manufacturers that we talk to. A lot of these facilities are around for a long time. There is significant investment when we build a manufacturing plant, and we want to get as much as possible out of this that we can. So 20 years old is not going to be a surprise, but within 20-year-old or older manufacturing plants, there's a significant percentage of the automation systems that are reaching end of life. One number thrown around, there's $65 billion worth of automation systems reaching the end of life. End of life can have a couple different implications. This can mean that the products themselves are going to be harder to come by. It's harder to even source the products, but there's also the in-house knowledge that used to exist for a lot of these systems is gone or is leaving. So we have the equipment that might be reliable itself. It might be in place. In this example, this might be in place for 30 years, which is great. Rockwell really does stand by their products. They believe in their products. They want to support them as long as possible. But at some point, the components used in the products or even the software used to support the products is just no longer feasible. So we have these components reaching end of life. This is a very, very common problem, common issue. That can have a couple different implications. One of those is downtime, and that's going to be a big focus of our presentation today is how do we mitigate this downtime as much as possible? How do we reduce that $20 billion number is the cost of unscheduled downtime. Plants have planned outages, they have planned downtimes to make upgrades, but what we want to avoid is when we don't plan it. When it's the middle of the night and something breaks and our equipment goes down, we can't produce what we're intending to manufacture. So our bread and butter is no longer something that we can make anymore. So we have all this unscheduled downtime we want to avoid. And this is going to be a big focus of our presentation today. The other focus is what can make this downtime worse is something when we don't have the components that we need. This can go from a very brief fix to an extended downtime, which can be very damaging to operations. And finally, on the other side, we're looking at legacy equipment as what we have, but we're also seeing a lot of notes about Industry 4.0 and connected enterprise, where plants are heading in the future. This slide here is showing something called augmented reality, and maybe that's futuristic in some cases, but that information like that data is going to be a prevalent part of all manufacturing operations. But we can see here that fewer than 14% of US plants are completely integrated. Their machines are completely tied together and they're connected and ready for the future. So why is that? Why is that 14% number valid? I think that most executives believe that this is what's coming. This is where they want to be. So why are we at 14%? And I think a lot of that has to do with it's difficult to get down the integration process when we don't really know even what we have or what step to take first. Moving away from general questions, let's look at some common ones that I think we all face. So when a part fails, we have that downtime issue. We have something that goes down, maybe in the middle of the night, maybe during the day. Are we sure that we have a replacement? If we go in the store right now and we had a part fail, are we positive that when we go in there, we're going to have the part we need? Once we get there, we go back and put it in our line, will it work? Is this something that we know is still good? It's from the manufacturer. We can take it out of the box, it's new, and we put it in and we have a high level of confidence going to work? Or is this sitting there out of the box? Maybe it was still good or new. Maybe it was something that was replaced 5 years ago. We don't know whether it's going to work or not. What condition is it in? And if we don't have it on site, does the supplier? Is this something where you can call the S&E and it's right around the corner and come pick it up? Is this a 30-minute exercise to get the part we need, or is this a 6-week lead time? These are important discussions that we don't want to be facing once the part fails. We want to try to address these ahead of time. Additionally, is it even still available? Moving beyond whether the supplier has it, is this something that's still actively produced and available, or was this discontinued 10 years ago and it's going to be an exercise to even try to find this part? Is the supplier that you're going to get it from trustworthy? Are they going to stand behind the product? Are they going to support you as you upgrade it? Or is this something where we're going to take a risk on even just buying the part and getting it in? You know, an extended downtime can turn even longer if our first attempt to replace the part is a failed part itself. And finally, are you getting the best value? Not just the lowest cost, but Am I getting the best value for what I'm doing? This goes back to that support function, and this goes back to knowing the part's going to work when I put it in. So in summary, this presentation is going to cover, are we protecting ourselves from extended downtime? And extended downtime is going to come from having the parts we need and trying to do so at actually a lower cost.